Hiya! So in this video, we're going to be looking at oriented vector spaces, kind of how to give some orientation to a vector space. But first, what we're going to be looking at is showing that there is exactly only two orientations. In other words, we're going to show that the two orientations we have seen, the same orientation and the opposite orientation, are really the only two orientations that exist. So let's kind of start off with that. So proposition 1.63 is basically saying if I start off with some basis B of a vector space, and I let B prime be a basis with an opposite orientation to B, I don't care what basis it is, just choose your favorite basis. We know from last time that this must exist. So we have just something. Now, so we have these two bases, B and B prime. They're living in the two equivalence classes. Now, if I take C, some arbitrary basis, I don't really care which one it is, just choose your second favorite basis. Now, we have only one of two options. Either C has the same orientation as B, or C has the same orientation as B prime. In other words, we really only have two orientations. So let's look at a quick proof of this. We're going to let T be the transition matrix from B to C. So T is equal to B, T, C. And T prime, we're going to let be from B prime, T, C. Now S, we're going to let be the transition matrix from B to B prime, right? So let's see. Now, we have one of two options. So one of the options is that the determinant of T prime is greater than 0, right? So if the determinant of T prime is greater than 0, this implies that C is equivalent to B prime, which is one of the two options, right? So we're saying it has to be one of these two options. This is one of the two options, so we're happy. So instead, we're going to assume that the determinant of T prime is not positive. We're going to assume it's less than 0. So let's assume instead that the determinant of T prime is less than 0. Now, using the same lemma that we saw before, that we can multiply the transition matrices, we have that T and is equal to ST prime. So remember, S takes us from, where's S again? S takes from B to B prime, B, B prime. And T takes us, let me double check. T takes us from B to C. This is wrong. This should be different. So actually, yeah, there's an error in the notes. So we're going to keep the notes as is. As you can see, sometimes we do have errors and that happens. But that's okay. We can actually fix this. So basically what we're going to do is we're going to go back and we're going to fix some things. So let's fix this. So what we're going to do is we're going to first start off with the determinant of, which way do I want to do this? Actually, no, we can just do this. We can just leave this as is. This equation I'm going to change to T prime is equal to S times T. T times B to C. Oh, no, this is right. This is T prime on the right. Wait, no, rewind. This is B prime. Oh, I'm an idiot. I wrote this wrong. Never mind, there is no error in the notes. And now this is going to be on video forever. S goes from B to B prime. T prime goes from B prime to C. And we're happy. I was thinking T for some reason. Dear brain. Goes from B prime to C. And so T does go from B to C. And we're good. Okay. Yeah, no problem. We're good. Now determinants. Sorry about that. So the determinants here, right? If I think of the determinant of T, this is just the determinant of S times T prime, right? These are the same. Therefore, I can kind of split these. And then I can also reverse these if I wanted, right? This is just big multiplication. In the notes, I have them this way, but it doesn't really matter which way you kind of do them. They'll be equivalent. So now since b and b prime have opposite orientation, we know that the determinant of S is negative. So in other words, what we have is the determinant of S is negative. And we assumed, right? So we assumed here that determinant of T prime is negative. So this is negative. And a negative times a negative, that's positive, right? So this whole thing is positive. That means the determinant of T is positive, and T, remember, is the transition matrix from B to C, right? T is B to C. So in other words, B is equivalent to C. So we're happy. Minus me screwing up earlier, we're happy. So in other words, we always have that there's only two orientations. So what we can do is we can actually give an orientation to a vector space. In other words, what we can say is we can give an orientation to a vector space. This is going to be, so an orientation of a vector space, right? This is going to be one of the two equivalence classes. So is an equivalence class of bases under the equivalence relation thing. And from before, what we basically saw is there's only two. In other words, we can think of these two being are the same or the opposite orientation. So these can either be the same orientation or the opposite orientation, and that's it. There's only two. So what we will do instead, what we'll normally do is we'll actually just say, okay, well, if one of them is the same and one's opposite, what we're going to call one of them the left orientation, and one of them we're going to call the right orientation. Now, it doesn't matter which one we say is the left, which one we say is right. We just choose one. This is just to have them separated. Because it doesn't really matter which one is the same, which one's opposite. We don't want to give preference, so we'll just call one left and one right. And this choice is arbitrary. It doesn't really matter. And then a left basis and a right basis are basically a bases that live in this equivalence class, right? So a left basis lives inside of a left orientation, or it has a left orientation. And a right basis will have a right orientation. Now then what this allows us to do is it allows us to define an oriented vector space. So what's an oriented vector space? This is a vector space with some choice of orientation. So we choose an orientation for our vector space. And what we'll do is we'll see examples of how this kind of works in the next video. So in the next video, we'll look at left and right bases, how they kind of work. We'll look at some like examples of them, and we'll play around with these a little better. So I will see you in the next video where we play around with left and right bases examples. Peace.